Hi, this is Ms. Peterson, and I'm doing the asynchronous lesson for week 6 here. And then I'll do the asynchronous for week 7, so pay attention for that one too, in case you missed today, Monday, the 19th. This is for week 6. Last week, we did a density lab, and we also reviewed week 5 homework, the I Heart Density. The intro question here really was, what would take up more space, a kilogram of feathers or a kilogram of steel? And so we looked at the density of the steel ball. It's at 8.05 grams for every cubic centimeter, whereas the density of feathers is only 0.0025 grams per cubic centimeter. So thinking about that, which would need to take up more space if we had a mass of 1 kilogram of each of them? Okay, and then we went through this right here, which was to talk about what would be liquid 1 and liquid 3. So if we look at liquid 2, it's water, and the water is 1 gram per milliliter, whereas the mercury is 13.5 grams per milliliter. And what would be liquid 1 and liquid 3? So if we look here in this box, and from the square list, we want to select that. Liquid 1 would have to be lighter. It'd have to float on top of the water. And so we take a look at the water. It's 1 gram per milliliter. So it could either be hexane or ethyl alcohol. So here, liquid 3 or item 3 would have to be between water, which is 1 gram per milliliter, and mercury, which is 13.5 grams per milliliter. And so only things that would be between those would be dichloromethane, aluminum, or bromine that could fit into the liquid 3. All right, whereas gold would definitely sink. Gold would sink below all of these things and go right underneath the mercury. So gold would not be able to be liquid 3. Okay, so what we're covering is we're finishing up density, and then this week we have our summative CER. And so that ends up being a practice CER and then a choice summative. So we did a practice CER and then a choice summative for this week. Okay. All right. So you're in this folder, week 6, CHEW, density, laboratory, and measurement practice. You're going to go to the Clever page, and then you're going to click Gizmos rostering. And that will bring you to a possibility of many different gizmos we've done. And the one that you're going to choose is density laboratory. All right. And that density laboratory one, you will do that in Gizmos. And even though you weren't here in the breakout groups, you're going to still do it on your own. And there is a student copy, density laboratory gizmo, you will download into Notability. And then you'll upload it back here when you're done. So let's go to that. First, I wanted you to see that in the slideshow, we have already reviewed density. And here you would find a picture of a gas and a picture of a liquid, and then determine which one is more or less dense. I'm going to let you go through that on yourself or by yourself so that I can go through the density laboratory. Okay, we're going to click into this bit.ly link here. And that brings you to My Teacher Clever page. And you should be able to see this page right here. All right. And hopefully we're still, projecting. And you go into Gizmos rostering, you click there. And you will notice that it will bring you to a page where you'll be able to choose, and yours might look a little different than mine, but you'll choose density laboratory and it ends up looking like this. And you are going to then go to the page that you have in Schoology, which would be the density laboratory gizmo. And so if you have that page open, it looks very much like this. The density exploration, density laboratory, or this one right here, which is the gizmo warm-up. And then also brings you through an explanation of volume if you needed a little bit of help with that. Now you can go through that on your own. here is the activity A. Activity A is the one that's required. All right, activity A. And we are going to go ahead and test these things out and fill out the table together. And then you can go back through and answer these questions and submit it. All right. And then if you can answer this exit ticket, then you are doing pretty well and you're on your way to understanding density. All right, so let's go back to the table. Well, first of all, you are going to go ahead and I'll pause this and you're going to go ahead and pause this recording and go ahead and make a guess here. Which ones do you think would float in water? And then write down, why do some objects float while others sink? Okay. Then we're going to go to, after you've paused, the density laboratory gizmo allows you to measure a variety of objects. Then you drop them in the water to see if they sink or float. The object's mass is the amount of matter it contains. Mass can be measured with a calibrated scale like this one shown in the gizmo. Drag the first object into the scale, and that's object 1. And so that ends up being this red triangle, and I'll demonstrate in a minute. Then an object's volume is the amount of space it takes up. The volume of the regular object can be measured by how much water it displaces in a graduated cylinder. So the initial volume was 400, and then we place this item into the graduated cylinder and it's 414, and then we figure out the volume of the object and it's 14 centimeters cubed. Now, while milliliters are used to measure liquid volumes, the equivalent unit, centimeters cubed, are used for solids because they have usually straight sides or they have dimensions that we can measure. So therefore, we write the volume of this object 1, because it's a solid, as centimeters cubed. All right, so let's go there. And we're going to put these items in. So you see that we put item 1 there, and it is indeed 19.5 grams per cubic grams. And then I put in the volume here, and it is 14 cubic centimeters. So 19.5 divided by 14, and we have an item that's greater than the density of water. So let's take a look and see what that is. So we go to the table here, and we do indeed see 19.5 divided by 14 gives us 1.4 grams per cubic centimeter. And as we go through them, you're going to go ahead and fill out this chart. I will go through all of them, and then you will figure out density by dividing the mass by the volume. Remember, I heart density when you do this, okay? So the M is divided by the V. So if you draw a heart, all right. Well, okay, I forgot I'm in slides. All right, I'll put that in there. All right, here we go. So we're back in the density gizmo. We got item 1 done. Item 2 has a mass of 11 grams. It has 9 milliliters or 9 centimeters cubed of volume. Okay, and it sinks. Going back, you're writing it inside here. Item 2 is 11 grams divided by 9, which gives you a density of 1.2 grams per cubic centimeter. Notice it sank. All right, the rest of it's on your own here. Number 3, 4 grams of mass, 5 centimeters cubed of volume. This floats. So you're going to write down floats. Item 4 has 135 grams of mass. Item 4 has 7 centimeters cubed of volume. And item 4 sinks. Item 5 is 4 grams of mass, 3.5 centimeters cubed of volume, and it sinks as well. All right. Item 6 has a mass of 78 grams. Write that down. Has a volume of 29 centimeters cubed. Write that down. And item 6 sinks. Item 7 has a mass of 2 grams. A mass of 2 grams. The volume is 21 centimeters cubed. You can see that right there. And item 7 floats. Item 8 has a mass of 24 grams, has a volume of 26 centimeters cubed, and floats. Item 9 has a mass of 99 grams, has a volume of 44 centimeters cubed, and sinks. Item 10 has a mass of 42 grams, a volume of 61 centimeters cubed, and floats. And item 11 has a mass of 65 grams. Item 11 has a volume of 40 centimeters cubed. And item 11 sinks. Item 12 has a mass of 104 grams. Has a volume of 114 centimeters cubed. And floats. All right, that's all for activity A. So if you go back here, you're going to go ahead and make sure that you take those mass divided by the volumes. As you can see, item 3 had a volume or a density that was less than 1, so it floated in water. And then item 7 also floated in water and had a volume that was less than 1, was 0.1 grams per cubic centimeter, and so it floated. Everything that had a mass that was greater than, a density that was greater than 1 sank. All right, so make sure you finish this column. Then you're going to go on to the next one. Does mass alone determine whether an object floats or sinks? I saw that there are some masses that float, right? That are large, very large sizes. So if we go back, we can take a look. This one floats. Same shape, different sizes, but this one sinks. So volume itself does not determine density. Volume itself does not determine density. What about mass? If we take a look at those same ones, we can take a look at the mass. Look here, 104 grams, and it floats. Okay, this guy is 4 grams, and it sinks. So it's really a dependent relationship between mass and volume. All right, so we go back and take a look here, and if you have to remember, I'll insert this little text box to remember that we have and a little picture, okay, for our I heart density here today. So there you go. So remember this, I heart density. And if we take this and we divide the mass by the volume, you got your heart, M divided by V, you'll be able to figure out the volume on those pages, okay? Go here, compare the mass and volume of the object. What is true about mass and volume of all floating objects? And go back there, take a look at all the ones that float. Which one is greater than the other? Is it mass or is it volume? Which one is greater? Mass or volume for your floating objects? Which one's greater? Is it mass or volume for your sinking objects? And then come back here and you're going to go ahead and write in what that relationship is. So 5, if you've already calculated the density of these objects right here, you've done number 5, which is what 5 asks you to do. And then you're going to analyze 6. Answer this question, is the density of floating objects, are they greater than, equal to, or less than 1 in this scenario? And what do you notice about the density of the sinking objects? Are they greater than, equal to, or less than 1? And then you're going to write your conclusion, which includes these relationships. So if we know the mass and volume of an object, then we know that and finish your sentence. That is the end of activity A. If you go beyond this, decide to do activity B or C, those are extra credit. Please contact me or let me know if you have any questions during office hours. And, they're usually like in the afternoon, 2 to 4. So just let me know, pay attention to the updates in Schoology. Come to class, come to synchronous meets. We do a lot of this work together. Therefore, you won't get behind. Okay, thank you. And here is your exit slip. If we look here, A is very much the least dense. C is the most dense at the copper penny. So what's in between? What would the feather be floating on in this scenario? It could be floating on the isopropyl alcohol. Then the isopropyl alcohol would be floating on the vegetable oil. Then the vegetable oil would be floating on top of the water. And at the very bottom of the water would be that copper penny right there. Okay, so good luck and thank you so much.